Okay, so just a reminder that our test is tomorrow on Unit 2, and I will be giving you all of these formulas, whether I give you the small little yellow piece of paper or they are actually on the test. They will be given to you. Please check Google Classroom tonight for an announcement whether the whole test is going to be tomorrow or I'm going to break it up into two parts, and part one will be tomorrow on Friday, and then part two would be on Monday, depending on our school schedule for Friday, and that depends on the volleyball team. So let's go ahead and talk about these different equations that you will be using to write equations of lines. So let's start with the slope formula. I think we talked about this yesterday, and you guys are pretty good at it. Remember, it is the ratio of rise to run, and it is going to be the difference in our y's. So y2 minus y1 over x2 minus x1. That is our slope formula that will help you find the slope whenever you need it. Slope-intercept form is probably the one you are most familiar with. Y equals mx plus b. All of our answers need to be in y equals mx plus b form. M is our slope in that situation, and b is our y-intercept. Remember, your y-intercept will always be given to you as a point, 0, comma, a number. And then for your point slope form, that's the longer one, y minus y1 equals m times x minus x1, where m is again your slope, x1 and y1 are parts from the point that I give you, and then the regular x and y are just x and y as they appear in the equation. So when you need to use point slope form, you will be given a point and you will be given a slope. All of your answers need to be in slope-intercept form, so you will need to solve for y. You will always distribute, and then you will add or subtract. Okay, so let's practice. I want to do number 22 real quick. Write the equation of the line given the slope and the y-intercept. So look at that given information, the slope and the y-intercept. It looks like the easiest way to do this would be to use slope-intercept form. So we are going to plug b and m into slope-intercept form, and it will look like this. Y equals mx plus b. So m is 1/4, and then we're going to do times x, and then plus b, which is 2/3. There we go. That's our answer in y equals mx plus b form. Then let's go to 24. Write the equation of a line that passes through the given point and has the given slope. Now with a point and a slope, we need to use point slope form. For number 22, that y-intercept was written as a point. You could have used point slope form and then solved for y to get to slope-intercept form. You would do it the exact same way. But this one, there's no possible way to just go straight to slope-intercept form, so we have to do point slope form. So we're given we're given your slope m equals 4, 4 is your slope, and then label your point x1, y1, and let's go ahead and plug that in. Y minus 7, y minus y1 equals my slope times x minus x1. Now notice what happens there at the end of that equation. That minus a -1 turns to a +1. So let's solve for y now. Distribute your slope. So we end up getting 4x plus 4 on the right side of the equation. And then we still have y minus 7 on the other side. Y is not by itself yet. We need to add 7. Remember, you add it to that 4 at the very end that doesn't have an x with it because it's not a like term with the 4x. So my answer is y equals 4x plus 11. You can go ahead and practice 25 and 26 tonight as part of your studying. All right, for this next one, write the equation of a line that passes through the given 2 points. So remember, we didn't review anything called point-point form. So here's my hint to you. Find the slope first. Then plug the slope m in one point into point slope form. Then solve for y. Distribute, then add or subtract. So step 1 is find the slope. So we're going to do y, or we can label our points x1, y1, x2, y2. And we can do 1 minus a negative 1. So that's going to turn to a positive. And then 2 minus 3. So we end up getting 2 over negative 1, which we always want to simplify to negative 2. So that was your first part, your first step. Step number 2, plug into point slope form. It does not matter which point you choose to plug it in with your slope. I'm just going to choose the first one. So I have my points labeled x1, y1. It's going to be y minus a negative 1, which changes that to a positive. And then equals negative 2, my slope, and then x minus 3. That is point slope form. Now, my last step would be solve for y. So I'm going to distribute. I still have y plus 1. And that equals negative 2x plus 6. And then I want to subtract the 1. So we end up getting negative 2x plus 5. All right, 29 and 30. When we get to those, these are a little bit different. Write the equation of line that passes through the given point and satisfies the given condition. So let's do 29 and 30. The difference here is obviously the points and the equations that I give you are different, but when you see that a line needs to be parallel to this equation, we are going to use the same slope when you see parallel. So the slope that you will use will be negative 3, and you are now going to take that and plug it into point slope form. So you would do y minus 7 equals negative 3, and then x minus 3. Point slope form, distribute y minus 7 equals negative 3x plus 9. Add your 7, and you get y equals negative 3x plus 16. That is obviously a different equation than the one that I gave you, but they have the same slope, so they are parallel. The only thing you use that equation for is the slope, nothing else. Once you find the slope, you use the slope and the point that I gave you to write the equation of the line. Now the next one will be different because now it's going through negative 2, negative 4, and it needs to be perpendicular to this equation, y equals 2x plus 5. So if it's perpendicular, we need to use the opposite reciprocal slope. So my slope there was 2. I don't want to use the same one. I want to use the opposite reciprocal. So that would be negative 1/2. So if we go ahead and plug in our point x1, y1 to this equation, here is what it looks like. I changed both of those to like a y plus 4 and an x plus 2 because they were minus and negatives. All right, then we distribute the negative 1/2 x. Negative 1/2 times a positive 2 is a negative 1. And then we will subtract 4. So we get negative, y equals negative 1/2 x minus 5. All right, now let's move on to number 34. Graph the linear equation. So when you see linear equation, you are going to be obviously graphing a line. That's important to recognize. And the equation is just going to be the line. No need to shade, no need to make it dotted or solid. We'll get to those eventually. So identify the slopes and any intercepts, that's important. So when we graph this, we are going to be wanting to look at what kind of form is this equation given to us in. This specific problem is given to us in slope-intercept form. So that means you will want to identify what the y-intercept is. This is in the hint. Then use the slope to plot at least 3 more points. Make sure you write your intercepts as an ordered pair. So when you go to this one and you're looking at the y-intercept, you're going to write it as a point, 0, comma, negative 1, because this is in y equals mx plus b form. And then your slope is going to be a positive 3. So here's how we do this. We go to our graph, and we plot 0, negative 1. And then we use our slope. That always has to be on the y-axis, that vertical black line. Then we use our slope to rise 3, run 1. It's a positive 3 over a positive 1. So I want to go up and to the right. And then I want to do it again, up and to the right. And then to get points down in this area to continue my line, I can go in the negative 3 and negative 1 direction for my rise over run. So down 3, left 1. And look at that. There is our line, our linear equation. Connect your dots. Now, for some of them, you will be able to just look at the graph and find your x-intercept. For this one, it doesn't cross at one of my points. It's going to be a fraction or a decimal. So I'm going to need to figure this out algebraically. To find the x-intercept, you plug in y equals 0 to your equation. So when you do that, we get 0 equals negative 3x minus 1. We will add 1. And then we will divide by 3. So x equals 1/3. And make sure you write it as a point, 1/3, comma 0. And that yellow point that I put on my graph kind of looks like it's at 1/3, comma 0, right? So that is graphing a linear equation in slope-intercept form. Now I want you to go down to number 37. We are going to graph each horizontal and vertical line. Remember Hooyvaks. That will be helpful for you. It will be on the side of the sideboard when we are graphing, when you are taking the test, all that kind of stuff, okay? So if you see an equation that says x equals a number, you don't see any y's there, you immediately think that it is a vertical line because it's not in slope-intercept form. When it's y equals a number like number 38, it is a horizontal line. You don't see an x. If you were to see an x here, then 6 would be your slope and 0, 0 would be your y-intercept. That's different. When you don't see an x, you automatically think horizontal line. So when it's a vertical line, we should think of the Vux part of Hooyvaks. So my slope is going to be undefined. And it's going to be a vertical line. It's going to go up and down, and it's going to go through negative 3 on my x-axis. So plot that point at negative 3 where it crosses your x-axis and draw your line. My x-intercept here is going to be at that point, negative 3, comma 0. And it is not going to cross my y-axis, so my y-intercept is none. Do not write 0. 0, 0, 0, 0 is a point, so I do not want you to write 0, 0. It does not pass through that point. Okay, for our horizontal line, it's going to cross through the y-axis. So put a point at y equals 6 and draw your horizontal line, left to right, like the horizon. You need to remember the Hooy part of Hooyvaks. So my slope here is 0. Do not write no slope. The answer is 0 for your slope because there's a 0 rise. There's only a run. It does not cross my x-axis, so my x-intercept is none. It's crossing the y-axis at 0, 6. That was that one initial point that I put on there. Okay, still graphing linear equations, but notice these equations are not in slope-intercept form. They are in standard form. So you are going to graph these a little bit different. I give you a hint. Plug in y equals 0 to find the x-intercept and x equals 0 to find the y-intercept. Then graph both of these points and draw the line. And then we will find the slope. So if you plug in y equals 0, this is what it looks like. Negative 3x minus 0 equals 6. Well, that minus 0 goes away, so I'm left with negative 3x equals 6, and then x equals negative 2. Make sure you write it as a point, negative 2, 0. Okay, let's go plot that on our x-axis. Your x-axis is the one that goes left to right, the horizontal line. So we are going to go left to and put a point. All right, now let's plug in x equals 0. So negative 3 times 0 minus y equals 6. So that first part goes away because anything times 0 is 0. So we get negative y equals 6. We want to divide by a negative 1. So we get y equals negative 6. So you're going to go down 6 and you are going to plot that point. And then we are going to draw the line that goes through both of these points. Remember, we will need straight lines on the test. So bring your lanyard, bring a ruler. I have extra rulers if you need them. All right, now let's find out what our slope is. So you can just count. You can rise 6 and run negative 2. So if you were doing the ratio of rise over run, it would be 6 over negative 2, which is a negative 3. You could also use, oops, I forgot to write this as an ordered pair. 0, negative 6 is my y-intercept. You could also use those 2 points to do the slope formula. So here's what that would look like. M equals negative 6 minus 0 over 0 minus a negative 2, so that changes to plus. And look at that, we get the same answer, slope of negative 3. My line is falling, so that's another good thing to look at to check your answer. All right, let's go down to graphing linear inequalities. So number 47. So if you look at the directions that are from above, we are going to make sure we identify the slope and any intercepts. What's important is this part. You're either going to use a dotted line or a solid line, depending on the sign. And there's those signs. Then I want you to plug in 0, 0 to figure out where you shade. If 0, 0 is on your line, then you need to plug in another point that is not going to be on your line. Okay, like 0, 1, that might be an easy point. As long as it's not on your line, you can plug it in. So let's look at this one. I chose this one because there's a fraction. Don't be worried about that, okay? We will solve it. This one's in standard form. So we're going to do it just like we were doing before. Standard form, we plug in y equals 0 to find our x-intercept. So we are left with 2x minus 1/2 times 0. And this, for this part only, the x and the y-intercepts, you can change it to an equation instead of an inequality. All right, so 2x equals 4. That means x equals 2. So our answer for the x-intercept is 2, 0. Go right to and plot that point. Okay, plug in x equals 0 for your y-intercept. So we get 2 times 0 minus 1/2 y equals 4. So we get negative 1/2 y equals 4. I would suggest multiplying by a negative 2 by the reciprocal, and you end up getting y equals negative 8. So to write that as an ordered pair, 0, negative 8. Goes right there. So since this is a greater than symbol, we are going to make this line dotted. So draw your line and erase parts of it, or make it dotted as you draw it using your ruler or lanyard. All right, now let's figure out let's figure out the slope first. You are going to rise 8 and run 2, both in the positive direction. So 8 over 2 leaves you with a slope of a positive 4. Your line is rising, so that's good. That makes sense. All right, the fun part, 0, 0 is not on my line, so I am allowed to plug in 0, 0. 0, 0 is a point right there. So let's see what happens. Is that a true inequality or a false inequality? 2 times 0 is 0. 1/2 times 0 is 0. Is greater than 4. So 0 is greater than 4. Is that true or is that false? That's going to be false. 0 is not greater than 4. So locate where 0, 0 is, that purple dot. I want to shade on the other side of the line from where 0, 0 is. I do not want to include 0, 0 in my final answer. I went over the line a little bit, just ignore that. You want to shade on that right lower side of the line because 0, 0 does not make your original inequality true. It makes it false. So that means it is not part of your solution set. If it were to make it true, then you would shade on this side. But it was false, so that's why you shaded on the other side. Okay, absolute value functions. When you see absolute value, you should immediately think that my graph should look like a V or an upside down V. Okay, so remember, this is our kind of like standard form of a absolute value function. We are going to use H and K to plot the vertex, and we are going to use A as the slope. Remember I said it was not the slope. And then we are going to use symmetry to plot things on the other side. The only thing I want to say about number 48, so H is always the number inside of your your bars, your absolute value bars. The value of H here would be 0. The value of K here is a negative 3. Remember, the value of H when it's inside of those bars is the same or the opposite sign of what you see. And then when it's outside the bars, it's the same sign as what you see. Okay, so my vertex for this first one would be 0, negative 3. My slope, my not slope, is what I've been calling it, is a negative 1. So I'll let you finish that one. Let's do 49 together. So look at HK, look at your vertex. Here is H, here is K. You use the opposite sign of what you see for H. So I see a negative 4, which means I'm going to use a positive 4. And then K is the same sign as what you see. You see a positive 2, so that's what you're going to use. This 1/2 is my A value. It is what I'm going to call not the slope, but it's going to help me plot my other points. So 4, 2, go right 4, up 2. My slope is 1/2, so that means I'm going to rise 1 and then go right 2. Rise 1, go right 2. Or we want to make our V, right? So we need to go up 1, left 2, up 1, left 2. Oops. And you can connect your dots. All right, this V does not cross through the x-axis, so there are no x-intercepts. And then for your y-intercept, you can see where that crosses the y-axis at. Looks like it's at 0, positive 4. The only thing I want to say about number 50, so my H value is going to be a positive 4. You see a negative 4, so it's going to be the opposite of that. In my K value, you don't see anything written there. It is going to be 0. So your vertex for number 50 is at 4, 0. And then this last one, I guess I should have done this one first. That's okay. So my H value, the opposite of a negative 4 is a positive 4. And then my K value is a negative 6. Now, I'll go right 4 and then down 6. There's your vertex. Remember, if it's a negative number for your A value, your V is opening down, okay? This one has a positive 1. So this one was the things that we start with, up 1, right 1, up 1, right 1. And I'm going to put a couple points on there, enough points so that I can see where this V is going to intersect, whoops, I messed up, where it's going to cross my x-axis and my y-axis. You will always be able to see where your x and y intercepts are on these graphs. Maybe not always on the linear ones, but on absolute value, you always will be able to see where it crosses. So my x-intercept looks like one of them is at negative 2, 0. And the other one looks to be at 10, 0. And then your y-intercept was at 0, negative 2. We just went down 2. So those are absolute value. Number 50 will be an upside down V. You can make a note, it opens down. And same thing with 48, it opens down. Okay, real quickly, last thing, piecewise functions. So all you're doing is plugging in the value of x that I give you to an equation. However, deciding which equation to use is the tough part. So if x is less than or equal to 0, then we are going to use the first one. If x is greater than 0, then we are going to use the second one. So think about number 52. X equals negative 2. Which one, which equation, the first or the second, do you think we would use? So negative 2 is less than 0, so we are going to use the first equation. And here's what it's going to look like. 1/2 times negative 2 is a negative 1. And then we want a minus 5, so we get a negative 6. All right, 53. If x equals 0, we are going to use which equation? The first one or the second one? We are also going to use the first one here because it's less than or equal to 0. When x equals 0, you use the first one. So 1/2 times 0 is 0. Minus 5 gets me a negative 5. And then for the last one, if x equals 1, we are going to want to use which equation? You're going to use the second one. And when you plug it in, 3 times 1 gets me 3, plus 1 gets me 4.